Our keynote speaker, Dr. David Rosero, joins us today from his role with the Hanor Company, where he is a senior nutritionist and technical leader. Dr. Rosero oversees the nutrition programs as well as the research and innovation efforts throughout the company. He's been recognized for his research and received such accolades as the Emerging Scholar Award by the American Society of Animal Science and a Research Innovation Award by the National Pork Board. And I can tell you from my experience with the Hanor Company, they are a pig production system that relies on innovation and is generally at the cutting edge of innovation and technology. So please join me as we bring back our keynote speaker, Dr. David Rosero, and he shares with us his experiences with smart farming under commercial conditions, and in particular, his lessons learned. Dr. Rosero, the floor is yours.
Okay, good morning again, Dr. Johnson. Can you hear me well now?
I hear you very well.
All right, please feel free to interrupt me if something goes wrong as we play with technology here. Okay,
we'll certainly do so.
All right. Good morning, everybody. Again, apologize for the technical issues we had before. I am honored to be here this morning and to start the discussion on the Pig Farm 5.0 revolution. I am grateful with Dr. Goncalves, the Swine team, and all of you that are joining this morning. I wanted to start this presentation with the year 2020 that we'll never forget. It is a year that brought us many challenges. It's a year of a pandemic that had also made us stronger. It's especially important for technology because it has accelerated the development of many technologies in the digital area and the Internet of Things and the smart farming especially. I believe this is the tipping point for us to move into the Pig Farm 5.0 revolution because things that we have done, small actions we have taken during this pandemic have produced big changes and have made us move forward faster. So as we move our society towards a smart society, by definition, this is the society 5.0. Agriculture is moving along to the 5.0 area, and especially for us big producers, as we bring together technologies, new technologies from the information system area, now together with the Internet of Things, to augment the capacity of the farmers to solve complex problems. So especially important into the adoption of the Internet of Things, as we saw in the previous presentation, but also the integration of that information into artificial intelligence exercises that then can lead to solving of the problems. This is our take on the Pig Farm 5.0 revolution from the commercial perspective. We believe digital transformation and smart farming have to come together as they will play together role into improving our systems. Along with digital transformation, we have business intelligence, cloud and edge computing, the management of big data, and then all of that leading to an artificial intelligence and the sub areas like machine learning and deep learning. All of this is possible because of the rapid development of sensors, as we saw in previous presentations, but also the application of robotics into our smart farms. I've just listed some of the key areas that our systems, commercial systems, are dealing with, and the impact of each of the technologies with intensity in green on how they apply to each of these systems, each of these challenges. For instance, we need to improve our efficiency into our systems and improve productivity and, of course, profitability because we have limited resources and we have an ongoing cost pressure. So technologies in the digital transformation will be very important, along with the Internet of Things and robotics. Things that we talked before, and I think it will make us better. And just taking the last point is, over time in our commercial systems, we are increasingly having challenges on having qualified labor. Robotics, Internet of Things, and artificial intelligence will play a major role here as we have increased reduction in the access of qualified labor. So information-based management cycle is going to lead us towards the pig farm 5.0 revolution. This is the data cycle adapted with the smart farming application as we producers in the field advance our pig farms through Internet of Things sensors towards computing system applications that now that we can integrate into cloud computing and edge computing, all of that integrating data into data lakes that now we can apply business intelligence softwares and statistical softwares for a decision process. This is what we're going to become even faster and better with the use of artificial intelligence. And finally, for us, it is very important to any of these in any of these technologies that can lead us into a decision to implement and have an action plan. So this is a cycle that we'll need to go through as we go into Pig Farm 5.0 revolution. So our approach from the commercial perspective, our approach to this revolution has been to establish a scientific base team and scientific based capabilities. Our objective for the Smart Farm team has been to evaluate the new technologies that can impact pig productivity and profitability that are accurate. This is very important. So the three things we look into every technology is that have to be accurate, they have to be reliable, they have to be implementable in commercial pig farms. We are not developers of technologies, but rather implementers of technology. And coming back to the tipping point, I think us, together with many of you that are in the early adopters, will be coming into adopting this rapidly and improving our systems. We have applied pillars that are important to these evaluations because of our scientific background and our scientific approach from the team. We apply these to evaluate new technologies. Also very important is the active collaboration with discovery centers in universities and private entities. We know we have to work together. We know that we together can move faster and more. So we have brought to our team very, very key people within the team that are data science driven and technology driven, but we have also opened doors to collaborate with data engineers, with innovative startups, to software solution companies, to business intelligence services. And then finally, what we do for the commercial pig farm has to be a data and financial driven decision. So this was early on into our process of increasing our adoption to the Internet of Things. We call it the Internet of Pigs, and this was our Hanor Smart Farm projects. And so in the way that I explained before, we set up our commercial farms, some of them into smart farms, in which we can implement and evaluate and improve with together with the companies, sensors, cameras, and information systems. So this is just an example of what we took it as a project. Now we have through 2 or 3 years within each of the sow farms, and one of the sow farms, one finished farm, and just testing technologies. Right here is a graph just to illustrate how we track the weights in different barns through the cameras where we have implemented, and how that is very common today to track environmental sensors. But we'll go deeper. So in our evaluation process of the technology, as I said before, we take a scientific and financial approach. So these will be things that we look to every technology alone, and is taking the same approach and is as our research capabilities. Is for environmental sensors, feed bean sensors, bar cameras, telemedicine, robotics for farm activities, just to mention some of the examples. How we evaluate the accuracy, reliability, and implementation. Again, the green color will show you how the intensity of the green color will show you how this has been improved, or it has achieved what we believe is optimal in accuracy and reliability. And then when we have passed that phase, we need to analyze if this is cost effective, of course. This is a technology that will help us to reduce costs or improve profitability. In the last presentation, there was some discussions about predicting the weight of pigs. This is an example I'm going to show today. It is as just taken as an example now, and this is only to show you how we evaluate technologies. We have achieved accuracy of predicting those weights, but we're working together with those companies in improving reliability, and I'll go deeper into what that means for us and the implementation. So we heard the last presentation talking about marketing processes of the pigs. This is very important for us, but we have to be able to implement cameras through the barn and through our sites and through our company. This will be very important for us, for instance, because we know it will improve revenue. It will reduce costs, having to feed the pigs extra as they have achieved an optimal weight. And this will be one of the key drivers for profitability. So going a little deeper and just taking as an examples on the smart cameras, and I'll have another example here. But my intention is only to show an example on how that collaboration and how that evolution with the companies have been. This camera is a camera that we collaborate with a Colombian company. In each of the squares you can see is the prediction of weights of each of the barns. The different dots are where we had in the pens where we had cameras. The blue line is showing you the first evaluation of the camera with their algorithm they had, but then improving the camera prediction. It is the orange line after taking individual weights and after improving the algorithm and the artificial intelligence software in the camera, we have achieved a very accurate camera in predicting pen weights. This is real data of our last test and validation. Again, improving the accuracy of predicting the weight. That's the variable we're measuring. This was conducted early this year, and this is comparing the actual pen weights versus camera estimations, and the graph is showing you the relative difference. So the colors are the two rooms where we have cameras, and then just presenting you box plots here. So as you can see early on the test, pigs were about 80 to 100 pounds. The accuracy wasn't as we expected, but we also didn't have enough number of pigs during that weight range to improve the camera. We were more interested into predicting the weight of the pigs as they have grown to close to market weights, which for us is around 290 pounds. The camera is very accurate at that point, and taking all together, we estimate that the average error for the two rooms were around 3%, which for us is achieving the accuracy. Taking in place, if we look into close to the marketing period, it is even closer to a 0% error. So that is very good to us. Now we're moving into improving the reliability and implementation. This is again data from our tests. This is from September 2020 to January 2021. This is a mistake. And this is showing the uptime. So the uptime for us is showing how many cameras are giving us data, pig weights in this case, by day, right? So here you'll see that camera 5 in room 1 only had 30% of uptime during that period, and the average uptime for the whole test was about 80.5%. We expect these to be above 95%, so we can say that 95% of the time a camera is providing an estimated weight of a pen. So that estimation has to be by day in our tests. And then moving forward, this is the step we have to move forward in the pig revolution, I believe, is the use of that information into making decisions that matter into our commercial facilities. So here is a diagram of the 4 rooms where we had the cameras in one of the tests, and the blue numbers are showing you the number of pigs that need to be taken out from that pen that have achieved an optimal weight. So as we improve the camera and the price become better, and we can put a camera in the whole barn, we can actually give a report to a caretaker to use that as a tool for marketing processes. But this is just an example of showing you how then we can apply this technology on the smart camera. I'm going to move quick here on the sound sensors and the stimuli. Some of you might be familiar with the SmartGuard technology. This is a sound technology that hears the squealing of a pig and stimulate the sound through an electrical pulse and preventing pig crushing. We were very interested in reducing that mortality early on the pre-weaning. And the SmartGuard team has developed a really unique system, I believe, but we have to test it under our commercial situation. So this is, for every trial we do for nutrition, veterinary, and genetics, we do the same for technologies when it's needed. So this is an example of what we did. Under commercial conditions, we tested the SmartGuard in each of our farrowing rooms and against our control, which is a camera without the use of the device. The SmartGuard without the use of the sensing device. So we want to have big numbers because, especially for mortality traits, we know we have learned we have to use large number of sows and leaders. And this is just showing you the example of what we use for implementing that trial. And this is just showing you some preliminary data, and to me, just to show the value and why we have to do, from our perspective, apply these or test these technologies using a scientific approach. When we tested this technology, we had to balance our sows by body condition because we have learned that the body condition at which sows have entered the farrowing room had a big impact on pre-weaning mortality, and also by parity. So as the sow ages, that also matters. And this very preliminary data is showing that early on, that for sows that have entered the room as teen sows or ideal sows, they improve the pre-weaning mortality, but not so much for the fat sows. We're going deeper into this data to understand more, but this is just to illustrate our scientific approach. Now, in taking the second part on the digital transformation, I wanted to go quick into an exercise we did with Iowa State University, having to integrate all the data that we now have the capability to collect into a very large data set that then we can analyze statistically. For this analysis and exercise with the team, we were focused on the impact of PRRS into our whole herd. And so we use about 3,000 closeout groups, but then tie diagnostics data, tie some of sow farm data, and all the data we were able to tie into this to understand it. And just to go quick into examples of these results, this is showing a relationship of the PRRS status at weaning. 0 meaning that this first 16 weeks after becoming a positive farm with PRRS, and this is predicting the wean to finish mortality. And we can see that those pigs that were weaned from that sow farm during those first 16 weeks have a much larger wean to finish mortality. This is important to us to understand as we do business models and make decisions. This is an example on how we use that data in the same exercise, but tied to diagnostics from Iowa State University, just to show what is the impact of PRRS if the herd became positive early in the nursery or later in the finisher, having a greater impact if the pig was diagnosed through PCR to be positive with PRRS early in the nursery. So we, in addition to these, just two last slides I show, we analyze many variables, and this table is showing you just an illustration of just a summary of the different variables that were key to understand. So now why I'm showing you is because this is important for us then to take it into models to make decisions. And examples of that will be the forecasting productivity, for instance. So taking 14 sow farm variables, The model that Iowa State University developed were able to account for 71% of that predicted variability in the win to market mortality. So very important for us to do forecasting of how many pigs will go into market, having to know what are the variables of the sow farm. This is still improving, and as we feed the model with more data, we become more precise. So now, and the next step we're taking with this project is to simulate the productivity and profitability. PRRS is a disease that impacts for many weeks, and that has a big impact into a farm if that becomes infected. So we first needed to analyze the data. Then we had to integrate a simulation model because we needed to input a time dimension into the model. As I said, PRRS might become a farm might become infected with PRRS for 30 weeks or 40 weeks or 50 weeks, and that has an impact into the business, right? It changes the parity structure of the farm, and then we wanted also to simulate the intensity of that PRRS impact and how we manage that PRRS impact into that very long time analysis. And then, of course, we needed to dynamic models for quick modification as scenarios. So here is just an example of what that process was into simulating the farm for 8 weeks. This is showing you the time in weeks and variables from the sow farm that included sow inventory. The gill entry, of course, we had to close the herd for some time, deaths that produced for sows, aborts, and the impact on the pigs born and pigs weaned and the full value pig at the end of the day into the market. And then we have to tie these with the economics, right? We have a dynamic market with diverse pig prices and diverse feed costs. So we need to simulate that as well. And at the end of the day, what is that meaning for our business? So taking all together, just to conclude the presentation, we believe that as we move in time and adopt smart farming technologies such as the Internet of Things, the real-time access to high quality of data, will improve our business and business profitability. But taken together with the digital transformation, this will increase even further. But the pig farm 5.0 revolution, which is defined for us as a smart, intelligent, precision agriculture, will take it even further. And with that, and just leaving you with this lemma that is very common into our team: in God we trust, all others must bring data. I want to conclude this presentation and appreciate your time and welcome any of your questions.
Thank you, Dr. Rosero. Excellent presentation. Really appreciate you bringing those concepts to us, particularly how you grounded robotics, the Internet of Things, or the Internet of Pigs, I love that term, and artificial intelligence, with the fact that these innovations have to bring value. They have to create improved financial situations for producers, otherwise they simply won't be adopted. And I also appreciate how you connected this to the labor challenges. Not only the labor challenges that we feel today, because they're certainly as bad as they've been any time in my career, but labor challenges we know have been an ongoing problem and will continue to be a challenge for our industry. We need to focus our technology solutions there because we simply don't have great other options. I do want to follow up and ask you a little bit about the pilot smart farms that you talked about. You mentioned that you have some barns that are smart farms today. If I'm another production system or another producer thinking about doing that in my system, do you have a recommendation on how many farms to start with, or what percentage of my farms should be smart farms so that I can start to go on this journey of the innovation 5.0, the revolution 5.0?
Very good question, and we are, early adopters, as you mentioned before too, and so we have to start with modifying and adapting farms, and just one farm, sow farm, one wing to finish farm. And the reason why is because as we adopt these technologies, we need to make sure those are reliable and implementable. I think we can take it as phases. Maybe one phase will be, farms where you can trust the data is collected accurately, that the systems will be working correctly every time, all the time. And then as you understand the technology, you can move to a phase 2, where you take a section of your company, say a region of your production system, and make it smart. I think as we move into that stage, then we'll understand better the financial implications of it. But we can now move farther unless we are confident on technology. That makes sense. So if you need numbers, we start with one of each phase. One smart farm in the sow area, one smart farm in the finish area. We're ready to move to our next phase, which will include, say, eight sow farms and 20 or 30 finish farms.
Yeah. Stage gate innovation process. Start with one, demonstrate the concept, and then expand it out from there. Where would you say you're at with your pig weights, the measurements through the cameras and the estimation of the pig weights? Where are you guys as an organization at on that journey? Still in the 1 barn mode, up to the 8 barn mode, or let's push forward and take this to the whole system?
So yeah, good question. So with the first stage, so the 3 points I wanted to bring back: accuracy, reliability, implementation, correct? We have worked together with the company to bring accuracy to a 97% in this case, which we are confident is better than the human eye. Now we're working towards reliability, and that's improved the system, right? Making sure the camera maintains clean most of the time, that it can be auto-sufficient with energy power, because if lights go off or power goes off, it needs to keep working. And then I think it's implementation. So we are, if we go back to the phases, we have completed phase 1. We're moving to phase 2 now. But that's going to take us a huge amount of efforts into improving reliability and implementation.
On the weight accuracy, is that a 3% or 97% accuracy on the individual pig, or the average of that pen?
It's the average of that pen. Yeah, we don't have a way to track by pig now. Maybe next generation technologies will help us to identify pigs with cameras. Today, we can do it in a pen basis.
You brought up a good point. The cameras are going to be better than our eyes. As you've given the farm the list and showed them 6 pens from this pen, 6 pigs from this pen, 3 pigs from that pen, have you went in and tried to understand the percentage of the correct pigs the farm removes from those pens?
Correct. Yeah. We have started doing validation. We call it validation test now, to see if the computer will simulate better those number of pigs versus what the people will select it. And I will say, for a second time we go into the barn to take pigs out, variation can be huge into the eye of the person. And that has improved by 5 to 10%, that accuracy of selecting the right pigs.
Very good. And then last question for you here, Dr. Rosero, before we'll let you go. As people think about implementing this technology, I assume this is commercially available. And could you give us some sort of a ballpark of what it would take for maybe a 2,400 head finisher or a common size barn in your system to have the hardware and software capability to do this?
Yeah, no, that's another good question. So we're working together with that company to make that financial effective. And at this moment, I cannot say that number, but I think it's something to think about. The companies develop Internet of Things and sensors and these technologies is as commercial farms, and we have a large number of farms to implement it. So an upfront cost will be a limitation if that's too high, right? So I think what I've seen some companies doing, and I really enjoy, and that's following other industries' technologies, is to share the initial costs and do an ongoing cost. And the benefit of that is you don't have to decide on the upfront cost, right? And then you, at any point, you can say, well, I have tested, I don't think it's bringing any value. And the other part of that is to we know technology is moving rapidly. So if I buy a camera today for, say, $1,500, $2,000, and implement into a barn, I know that in a year or two, that's going to become obsolete, right? So then that's the old question in the financial decision. And that's what I think this new model into sharing the cost, but then doing an ongoing cost will be very valuable as we move forward.
Very good. Thank you very much, Dr. Rosero. Thank you for your wonderful presentation and for answering our questions.